Okay, thank you to be here again this day for let me say for continuing the lecture of PSO. Let me restart, nevertheless, from the software. I don't remember if I uploaded the software. Probably yes. You look if my study you have two programs, one M file, two M files. I think it's not there.
It's maintenance.
Oh, in maintenance. Oh, better. So I can say everything is there. But it's no problem. I will upload. Please, let me say, pay attention on my words. Stop me anytime. We have 1 hour, excuse me for today. But I hope that I will be able almost to conclude. But independently of the program, please stop me if something is not clear. Very important, because this is I would like to say the last topic in optimization for control, for identification, as I told you, and then we will start next week. In any case, it could be that I need a little bit to tell you something more about PSO, but just for completing, yeah. Let me now open MATLAB. About MATLAB, I started to work on the sense to tell you. Let me see. Okay. MATLAB. To open MATLAB, click twice on the icon. You remember last time I told you that the program, for didactical reasons, I split into two parts. Which program? The program to calculate a minimum of a problem which typically we don't, in which typically we don't think about to apply a PSO. Why that? Because the problem which I am presenting isn't a convex optimization problem. This means why I have to use PSO? Probably I can use any kind of other methods. Do you remember? In fact, let me come back to the formulation problem, which is an artificial problem, in order to discuss, in order to understand the structure, in order to understand the limits on PSO, in order to analyze how PSO works. And the problem is defined in this function, output function. I don't know if you see here on the left. Look at this. If you click twice here, you can open this M file, which is in a function. Very important. Function is written here. Do you remember in the middle of this structure of this frame, you can see the possibility to write something. To write something. And in this particular case, in this program, we have the function. It's written at the beginning. Function is not a main program. The function is a program which must be called from by a main program. Of course, I can organize in a different form everything. I can organize much better, or this is the meaning much better, within less number of commands. But I am not here really to learn programming. I don't have time. But I organize the lectures in this form because I think we can understand better. Not only we can learn also how I can use the function. Sometimes it's more useful to organize, to solve the problem using functions instead of one program. I don't know if you understand me. The engineers understand. It's boring for engineers, I think. But it's not boring. Yeah, it's funny, better. It's in a function, nevertheless, it's in a program, which is called by a main program. Now, in this function here, the name of this function is this here, output function. And here we have this function here with this name here, with an argument x, if you remember math, no? F of x, f parenthesis, x parenthesis. in which x, in our case, please pay attention, a little bit difficult, isn't a vector. Concept a little bit abstract for us. But in any case, a vector means some variables. 1, 2, 3, depends. It depends. Then here I define my function to be minimized. It's written here. Very easy today. I change also because some student asked me something about that. You remember last time I started with 2 dimensions. Now easier, 1 dimension. Of course, if I have this problem to be solved, to optimize, this means to calculate the minimum, because this function here, I don't know if you remember, in the parabola. High school, do you remember a little bit? The parabola, the minimum of this parabola is at x equal to x1. In this case, is redundant because we have just 1 variable for the function. But let me write 1 because we can extend the problem in the large dimensions. Meaning of this. Before explaining a little bit better, the minimum x equal to, or the x1 equal to, and the minimum is 100, clearly. Why is it stupid to attack this problem with the PSO? Because we can calculate by hand. Let me see, indirectly, even though it seems to be in a contradiction, indirectly, but means not directly with the numerical method. Analytically, let's forget directly and indirectly because it's a little bit confusing. Directly means, I come to you, directly means, thank you for the question. Directly means direct with numerical methods, because typically in optimization, we don't have very often convex optimization problems. I'm using here to explain better PSO. Why that? Because to validate the PSO, to discuss the PSO, I have to know the results. The result in this case. The result is x1 equal to the minimum, and the value is 100. Question? Okay, please inform me because sometimes I forget. Yeah, thank you. Please also from home, stop me because sometimes it's impossible, for instance, to see the chat. Now we can see from here. Now I see, but now I don't know anymore the chat. Please stop me. Thank you. Very important. Very important. Also for Zoom, no, because Zoom otherwise. Other questions? Not. Let me. The concept of the validation is clear now, because if I don't know the results, we cannot discuss valid, not valid. Of course, in the reality, assuming that the reality exists. Yeah. We will insist on this concept in the next semester. If you like to hear my funny things, you can really understand better what I intend using Kalman filters. If you digit Kalman filter is used everywhere, at least in control, in modeling, in predictions. And did you hear about that a little bit? Kalman filters. Kalman was a famous professor. He concluded his career in Zurich, ETH Zurich University. And he was the pioneer. Is invented, discovered. I don't know how to say invented, discovered. Probably is better. This interesting algorithm. I don't have time in this course because it's in a course dedicated to Kalman filter. Here, validation means look if I am able to concretely in this case. Look if I am able to find x1, if you like, equal to and the minimum at 100. And changing some parameters of the PSO, for instance, the number of particles, or we will see together the weight, what change? How robust is the solution? Look a little bit what I intend in one word, so in a few words. Let me switch on the lateral camera. Why does it work now? Probably. Yes. Why not? 1 second, I have it here. Now, you remember this picture last time? Let me show you a little bit better. Last time I sketched, now we will go a little bit in depth in this lecture. Our case is this one. We have just to find the minimum with respect of x1 in our notation, or in our notation here y, for instance, in the matter base x1 or x, assuming that this is the minimum. X or y equal to, or the y star, you know, a little bit, you can find different notation. We will see that really we don't have such kind of function, because in the computer, it's a shame, or at least in this kind of computer, we have a function which basically looks like it's a red function and not the blue function. I mean, it's not flat, as in ideal, let me say, word in reality, in ideal reality, but we have some valleys and hills. Do you remember the concept of valley, hills, mountain? This picture at the beginning. Where this come from? We will see that they come from the discretization, or if you want, digitalization. Now we speak about digital, but better to say discretization of the surface, in this case of the function. Because the computer, this computer, our computers, represent any function in discrete form, if you want, digital form, if you like, but I don't want to now to distinguish this wording, but we have a difference. Digital, discrete for us is the same. This means it's not exactly in a flat function, or representation, but numerically it's something which looks also not in this form here, but stepwise constant function. Now, also the red is a little bit ideal, because really looks like something, I don't have another color, looks like something like that. Yeah, probably you have the minimum, but you have many minima because the representation is discrete. This means we will see that we'll never achieve x equal to, we can round, of course, but we have to be aware that the minimum x equal to does not exist exactly, but we can approximate nevertheless somehow. But we have to keep in mind for different reasons. Let me coming back to our, we have another, no, we have now to analyze, we have to analyze the main program. Click on the main program. As I told you last time, we can see that this is the main program, which is a simplification of a program which I realized in ABB. We generated, not with this program here, but what inside in a big project. Also, with the big project, 2 patents. Why I told you last time why this information? The information is important to, otherwise it's not so nice, no, I hope. It's important because in order to tell you that this kind of software, this kind of method, better to say, with its software, can be really applied in the practice, no? In the applications. Because you know that to realize in a patent, the system, or the idea, let me say, the idea must be original and must work, because costs money. And ABB is the company, I don't know if you know a little bit. Heidelberg is known. Each company does not invest money if the system doesn't work, because to defend a product which doesn't work doesn't make sense. Tick together with tock, we can use to calculate the time, the calculation time between the command tick and the command tock. I will tell you later. I think I cancel the tock because I don't want to see in the command window the calculation tab, but I can do. It's enough to write tock somewhere. Between tick and tock, the system, MATLAB, in the sense the system MATLAB, calculate the calculation time. Is an important function, not really extremely important, but nevertheless can help us if between tick and tock we have to modify the program, we have to add some comments to improve, to change, and we have a feeling how much cost this change in terms of time. This means also in terms of components. I'm not able to explain very well this, but of course, if we need a lot of time to solve the problems, it could be that in order to speed up, we need circuits, hardware that probably more expensive, or we can decide don't use. But of course, what is important in general is not exactly the time, even though it's a relative indicator, because each computer has its microcontroller. This means depend on which microcontroller you're using. But in any case, relatively can be considered, because without this modification, I have 1 second. With the modification, I have 100 seconds. This means I need 1,000 more power in the calculation time or general hardware. Yeah. Yeah, let me show you what I intend. Yeah, it's just the measurement. I show you 1 second. Please pay attention on what I intend. Let me put here tock. If I run the program, you can see a little bit an error. Is it 100 but 110? We can see it's not 2 but 3. We will analyze later why that. Let me see where is this tock. Yeah, to see this, I have to comment because he printed each time to analyze. 1 second, I show you. I have to put a semicolon here. Semicolon means don't print in the command window each time the gbest. And I think I need also, in fact, to put a semicolon here. Otherwise, each time it prints the value. Let me see now if it's working. I don't use much, but should say that's the time. Yeah, we can see here. Between everything which is to do, which we have to do between tick and tock, it takes 0.14. Now, just abstractly, I don't have time, but in the program we can use. If I ask in the project we can use, please try to do this modification and analyze how much cost. Now, this question formulated in so general form can be answered in terms of time. Of course, we respect before I would like to say the changes, we can estimate cost 10 times more. 10 times, now we can quantize in terms of hardware, in terms of money. Or in general, if we have a limitation on the hardware, we can say we cannot apply. Because this hardware is not able to give an answer in this time. Typically, this is the problem of control, nevertheless. Why that? Because in control, we have to answer inside. We will see starting from next week. And a sample time. I mean, if I have to control my car, my auto parking for a car, if I have to stop the car before, because I have to get down, of course, I cannot stay in the car 1 hour. This means everything should run quickly and quickly in the sense in our reasonable time. If I have to monitor the movement of a galaxy, of course, you have more time probably, no? Because in this sense, it depends of the phenomenon or of the phenomena which I to be considered in our context. Okay, let me analyze now the software. Now we are should be nice if today I will conclude with the analysis of this software. Next week we will conclude introducing a real problem, the original problem which I told you, which I introduced last time. This robot, which is moving to realize a flat surface. Look, CLC, I think, is just a prophylax command which clear what we have in I think in the command windows. I don't remember, but we can see. Yeah, it's not so relevant, but anyway, we do typically clear all in clear and close all, clear all variable which we have active in the workspace. It's not so extremely important because we can override, but this is a common used command which we do always each time we will run. Close all is quite important because if I remember well, close all figures. Otherwise, you have a figure everywhere. Check again, help, close. But it is not now extremely important to analyze this. Format long is in a command which is used to formalize very important word, the solution, the values and things which I will print or which I want to represent in the possible long format, but how possible to say does not increase the precision of the machine. To increase the precision, please note, you have to use that time I told you. Choosing a command help VPA, something like that. Let me see if I remember well. Together with digits, something like that. Yeah, it is. This can be used if you want to work with the maximal precision of the machine. It's not, in this course, extremely important to analyze this. Now, nevertheless, I put this format long because we will see later I needed to do some considerations for in terms of results. RNG default is the way how I generate this random number. Do you remember I told you that the PSO, particle swarm optimization method, is based on a random principle. These birds will move randomly. And if you write help RNG, you can see that you can consider different distributions. If you consider RNG default, you are considering basically as a uniform distribution of random numbers between 0 and 1. This means if uniform with a mean value 0,5. Of course, we have here in this my lab we tested also PSO using, for instance, chaotic random number. This could be an interesting project with us. With this, the chaotic. I don't know if you learn about Lorentz attractors or attractor. Anyway, we can generate chaotically the numbers, and this means not uniform distributed. But also, this is a little bit too advanced now to speak about that. In the project, we can nevertheless, I can give you this topic, and you can go in depth on different variations, in the sense, variation of PSO. This F-mean plot we will see today is in a way to represent a vector with, let me say, infinite dimension, even though infinite for us doesn't mean anything, but I can, we will see at the end, include in this F-mean plot many values, the results. I plot the minimum of the function which I find each step, theoretically infinite, but of course infinite doesn't mean anything, theoretically until the overflow of the machine. This means this vector here is not defined as a vector with 3 elements, but as the computer can, the maximal element which it can. Look, in our easy example, we assume that the minimum is between 3 and 4, but it's not. Do you remember? Our minimum was x equal to. There are 4 PSO found something strange. I will come back on this later. But let me show you what happened before. Because we have 110 and not 100. Why we had 3 and not 2? Yeah, because we assumed that the minimum is, or was, between 3 and 4. Let me look. How clever is PSO? Ah, look how clever is PSO. I assumed, look at this picture here, that the minimum here inside. Because do you remember LB and UB as the lower on the upper bound, in which we thought, a priori thought, where the minimum is. Of course, if I don't know anything about the position of the minimum, I have to write LB equals minus infinity, infinite, UB upper bound plus infinity. But in order to find something between minus infinite plus infinite, I don't hope that we will find the solution, because the search room doesn't make sense. But if I don't know anything, of course, I have to extend my search region. I mean, if I say, please pay attention, excuse me if I trivialize, but I think, please pay attention, in this room, there is my key. Where is my key? And my hand. Of course, it's different if I say, please pay attention. The key is in the campus. And then we will see another problem important on this. How many people help me to search my key? Now I tell you an interesting thing. If I say here, coming back to this problem, if I say it is the minimum here, but is not here, I don't know where it is. Now I know where it is. Therefore, I told you the reality does not exist. Because now I know where it is, because we are working in a simulated reality. But really, I don't know where it is. Now I know because I put it. If I put what I understand what I say, why I put it. I define my reality. If I am able to define my reality, I have a pseudo reality. In fact, I say my reality. Therefore, I am telling you the reality does not exist. My reality is your reality, but the reality does not exist. Because we don't know where, in the real problem, let me say in the real problem, where the minimum is. Look, if I assume that in my, we can organize some game if you want. No? Try to, I put the minimum somewhere, and then you have to build the program to find my minimum. No? And you try it here. No? You say, in my opinion, Paolo, put the minimum between 3 and 5. No, no, what I told you, excuse me. 3 is minus, I don't remember. Let me look. Because probably it's stupid also the picture, no? Okay, now I change it, 3 and 4. Okay. This means it's 3, and this is 4. No, that makes sense. The lower bound is 3. This should work. Why doesn't work? Let me see what is the problem. Let me run. I change it, the lower, the upper bound? No. Strange, that doesn't work. Let me see, let me analyze. Let me prepare. Yeah, let me see. Yeah, excuse me. It's okay, no? Main program. Okay, let me see what happens. Why does it work? This and this, in order to look at the solution. Let me see. well, let me see why it doesn't work. Probably I changed something. And then let me see, let me analyze the program. Okay. Clear. Everything is okay, but the picture is not okay. 1 second, excuse me, this was another example. Yeah, the picture is here. Here's my minimum, let me represent here. And I analyzing between LB equal 3, now it makes sense. And UB equal 4. I am thinking that the minimum is here in between 3 and 4, now makes sense. No? Here was another example, excuse me for the mistake for the confusion. No mistakes. The minimum is at the point x equal to, but I am supposing that the minimum is between 3 and 4. Now we will see why analyzing the software, that the PSO sees that the minimum is at 3. Makes sense, because in this interval, in accordance to this picture, this function here, depicted in this form, the minimum is here. Because between 3 and 4, in this monotonic part of the function, the minimum is exactly here. It's not 100 because it's here, but it's, for instance, I don't know, 110. I don't know if it's clear. Because the minimum realized that the function is decreasing monotonically. If here inside we had in the local minimum, the problem is in this case not complex, PSO will find the local minimum inside. Now we will see why. Again, in a word before continuing about the, you remember this stupid example, look for my key in the campus, or look for my key in this room. It's clear that look in the campus is more difficult to find, or at least in a reasonable time. Therefore, TikTok, you know, probably have to variate, have to program, have to involve different people in this sense. In fact, and a crucial point, how many elements I will involve? Not only, it is a little bit complicated in this course, how many swarms? Because I can say one swarm is looking in this room, one swarm is looking in another room. This is a little bit too complicated in this course, but we can, in the lecture, we can consider in projects. I will explain a little bit better formulating the problem. But what I would like to say, this is, we understand very well in a stupid example. And not, I mean, to find the minimum, of course, depends of the density of the particles. I mean, I can assume that if I try to find my key here in this room, could be, I don't know, difficult. I can spend of time. I can assume if you help me to look at this, to search this key. If I need alone, I don't know, 1 day. Let me say, with 2 people, probably we can achieve the result statistically half day. Why not? It's not exactly so, because the problem is not so linear in the sense, but let me say so roughly speaking. Of course, if you consider 4 people instead of half day, we can consider a quarter of day. Why not? Let me so assume that the time decreasing linearly in the sense. But believe me, if you have 1,000 people, it could be that never find the key. A little bit too difficult to understand, but the example, the optimization can be done in a different problem. To build my house. Alone, I need 1 here. 2 people, you need half here. 4 people, I need 1/4 here. 1,000 people never finish the house. Why that? Because in the optimization, also in the software here, The problem is to coordinate. The problem is to arrange the work. Somehow it's reflected also here with P best, G best, in particular, G best. The particle or the element which say search there, search there. If you have to consider 1 million of particles, it's not so easy as to find something, not necessarily easier to organize the search for 100 people or 100 particles. This could be also be very well understood, no? Because sometimes we will see also here in some example, not necessarily increasing the number of particles, we find a better solution. In any case, we involve more time, a lot of more time, because you have to move and a larger, let me say, swarm, not big matrices. Let me go ahead now. This concept is clear. No, not necessarily to build a house. We reduce the time, achieving the result, increasing the workers, because very important is to coordinate. Very important how organize the program here. Because otherwise, we can realize a little bit also in this easy problem. Even though here increase the particle, typically we increase the precision, but in any case, we increase also, as you understand, I can do in TikTok, the time. No? This means also, when I say never will build the house, never will achieve the result, could be seen a little bit also here. Because if I consider 1 million of particles, it could be that tomorrow in the morning, I will have the result, assuming that I will have. Look, m equal 1 is the dimension of the problem. X1. I call dimension means how many variables I have to optimize. Do you remember in the robot we have omega and V? If you think in gymnasium, here, do you remember to find the minimum here, we have an X star and Y star. Here means in this case here the dimension is 2, the dimension of the problem. Typically M. In some literature, in the software, is the dimension of the problem. Here, the dimension is 1, no? Like here. Here, the dimension is 2, because I have to find 2 elements which localize where the minimum is. Do you remember this picture here also last time? I called level of curves, no? This section and so on. We can see here we have a minimum because these curves is concentric and the level of this curve decreasing and toward this point here, which we can assume to be the minimum. I don't know where it is. It's not 100 because if it is 6, this is 3, could be 1, or it doesn't matter what. It's clear this level of curves. Or level curve, something like that. Look, n particles, looking for the minimum in this case, we will see increasing what happens. Do you remember this W? This W was the weight. Let me a little bit go ahead here without coming back to the lecture. Look here. This W, which basically change between Vmax and Vmin in our program in accordance with the change of iteration. Iteration, let me say 1, we have close to minimum. If you consider iteration 0, we have a Vmax. Iteration equal maximum iteration, we have Vmin. I don't know if we can see, because this divided, this is 1. And what is this W? Remember this is the weight, an additive weight, to adapt let me say, the velocity. I would like to say the velocity. I will come back on this concept here of my swarm, which is a function of the past velocity, but multiplied by V, which could be constant. In this case, a little bit more complicated. I am considering this in order to show you that we can consider different parameters which weight this element. For instance, I can consider different C1, different C2. In our lab, we consider really also different C1 and C2, but it's also already complex to explain you this W. But W is the parameter, could be fixed, but could be in accordance with this definition here, depending of the iteration, starting from iteration 1. Let me consider iteration 0. W change starting from W max, in which iteration equals 0, until W min, in which iteration is maxima iteration. Now we can see here, if iteration is maxima iteration, we have V max minus V max 0 minus V min min. What is the meaning? The meaning is that through the iterations, I will try to reduce this exploration region, because I will reduce this vector and I will concentrate just on this vector and on this vector. We will reduce automatically, we will see how later, even though randomly, because R8 and D, which depends of my R and D, which I defined at the beginning as a way to define the random variable, are uniform, distribute random number at each step changes between 0 and 1. Too difficult, my language? We will see now a little bit. I will insist also next week, because I see perplexed question. Look, now I simplify a little bit. We will come back on this min and max later. C1 and C2 fixed equal to. Why that? Because the random number, in accordance to our definition, uniform distribute between 0 and 1, mean value 0,5. At this moment, we want weight in the same form, the same way. The mean value is 1. Of course, multiply by 2. Why that? Also, too long discussion. We can also additively change over the iteration. But let me go ahead, otherwise too complicated. Here, don't care about that. Because of course, I can think that I can try to test during running the software in an intermediate step. Look what I intend. The maximum iteration 1000. This means why not to check a little bit earlier what happens? I can stop before 1000. Why that is important? Because I told you one important issue, how many seconds, let me say second, in order to be concrete, I need to have the solution. If I want to build my house and I need 1000 years, probably I renounce to build the house, because I can see for me this is not important. This means also the time is important. You can think that we can organize the software considering also some checks in intermediate iteration. But just to flesh out, I don't implement this, because otherwise too many information in this sense. Maxima iteration we can understand. I mean, I will look for my minimum 1000 times. In our case, times means steps or number of iteration. Maxima loops, okay, this also too complicated it's not complicated, but too many information. I can consider many swarms. One is dedicated to this region, one is dedicated to another region. I can really, with fantasy, to organize the different totally strategies, which works parallelly. Or if not,
I've just got a question for the iteration, for the amount. So with every iteration, it can only stay the same or improve, because you can always find like a better global minimum. So how do you know what really is the sensible maximum iteration number?
Yeah. Thank you for the question. Therefore, the maximum iteration, thank you, very nice question, makes sense just together with this. Because from time to time, I have to look how it's going. I mean, if I realize that we have a stagnation, stagnation. I don't know if my pronunciation in English, stagnation. Yeah, in German, stagnation. Stagnation, no, in English, something like that. When I realized that how I can realize. I'll show you later. It is a way to do. When we see that no improvements between some steps, this means the particle, we have a stagnation of the particle, remains in some region. This means the question is, probably it is better to stop. This means no indication about the maximum iteration. You can put really a lot, a million, infinite theoretically. But in this sense, more sense than maximum iteration is to check intermediate iteration. But I don't want to put here in this lecture also this check. Otherwise, the program is too heavy. But thank you for the question. No indication about the maximum iteration. Theoretically, you can put infinite, extremely large, but very important to check from time to time if you have a stagnation. If you have a stagnation, we have to do something against stagnation or stop. Okay. This means maximum iteration. For instance, now when I work on this topic here, we put, it doesn't matter what, very high, extremely high, very important to check what happens.
So the algorithm is like you check like for every 100 iterations, and once the improvement becomes under a certain degree, you just stop.
Yeah.
Okay.
Now the question is, how often I have to check? And what is the tolerance? If you improve, I don't know, 10 of, I reduce I improve my minimum of 10 of -6. Typically, very important, and how much time do you have at disposition? And the microcontroller typically depends of the, not typically, depends of this process which we have to control. But if if I were to control a very fast phenomenon, of course you have really a short time. This means this is the real problem. This means you have to be happy very often what you have in microseconds. This means a few number of particles, and yeah, very check very often and to interrupt. Of course, in this case, we have probably local minimum, and yeah, this is the limit. Of course, if you have infinite time, you probably find the global minimum. For instance, the example to build in a house. If somebody asks me, we will build your house is, if say to me, we will build my house is 100 here, I can think probably of my son, my family, but for me, it probably doesn't work right to start with project. It's not optimal for me. This I try to give just a feeling about this kind of problem. Thank you for the question that we have in this, in this kind of formulation. Maximal loops, one means I can consider just one swarm. Here could be done something in project. I mean, we can split the search work in different regions. Next week I will bring some ideas, but I don't have time really to. You have to know that in PSO there is also PhD programs. If you look, University of Stanford, it's not the last university. If you digit PSO PhD thesis, Stanford University, you find a list of published in PDF PhD programs, PhD thesis at the Stanford University. Look, if you have a Google, this means isn't a topic, it's a very huge topic. I give you just some flashes, believe me, but extremely strong. Think about that. Stanford University is not the last university. Invested a lot of energy in this sense, in PSO methods. Also, we have a different and interesting results. The last one is the result of a study of mine in this course. Before last semester, we received, at the end of the course, I will show you the best paper awards in the conference with PSO, variation of PSO. I will show you later in order to motivate you in this course. Of course, he invested time after, but in this course. Did you believe me? Okay, this sentence here is not to be commented because it's the function of, again, the different swarm. This means don't consider this. Also this one. because this is the function of this, which is the function of what we then consider at this moment different swarm which work in the same search region, but with different tasks. Yeah, I would like to, roughly speaking, saying so. I don't have time to tell you. Look at this. Here's again this loop here, which is the main loop, which includes all possible swarm, is not to be considered because it's running from 1 to 1. This means it's not running. I mean, it's running once. We have just, this means just one swarm. Very interesting now, this. For 4, which, excuse me, these 2 for loops close with 2 end. I don't know if you know a little bit for loops. I have to explain a little bit. I think I will dedicate also next week to PSO because I see that perplex. It's difficult for you, no? A little bit. Extremely difficult. Too easy. Okay, let me explain for. No, very important to understand that it's not really, again, important to do many things, but very important to do a few things. But I hope good. If nobody understands, look at this for these 2 structured for loops. The meaning of this command for, we can recognize the command for with the color. No? MATLAB gives the blue color to the function, to the operators, let me say. Do you remember last time I told you about the matrices with which we represent the movement of this world? Should I come back of the lecture? Or that is okay? But it could be here. Here, I don't need exactly now to explain the movements. I need just to explain the 4. Why that? Because here, we don't have a movement yet. Here, what I'm doing here, I randomizing the initial position. We are still in the initialization of the program. Please pay attention. A program consists of a running part, which is exactly the movement of the particles. And the running part will represent the movement of the particles in my search region. About search region is clear, no? Between 3 and 4, or better to say between 1 and 4, so I can find the meaning. But in order to move this particle in this search region, I need to initialize the position of the particle. We say that the program consists of an initialization part and then the running part. We are still in the initialization phase because I didn't define the movements. What I have here, thanks to these 4 loops, I randomize the position of the particle, and I put the particle in this matrix here. Do you remember the matrix represent our swarm, in which in the row I have the particle 1, particle 2, until particle n, I think, no, yeah. And m is the dimension of the problem. This means the coordinate of each, or coordinates, in this case is coordinate because m equal 1, just one coordinate, of each particle. This means what I am doing here, at the end, and now I clarify better, of this 2 for loops, is to full a column. I don't know if we can see, because n is from 1 to n, and a column of n birds with the coordinate calculated randomly between LB and UB, basically inside the search region. Let me explain a little bit better. First, particle. This is difficult for not engineers. Look, I will repeat. This is important to understand. This means for I equals 1 until n. I can define n. I put at the beginning 20. This means I involve you 20 people to look at my key. And I say to you, the key is here. But you have seen that the key is not here. It's in the room. Because the key is at point 2, and I put here between 3 and 4. Huh? Why that? Because I am joking. But we can understand that we don't find exactly the key. But we will see next week. But the system say, please pay attention to have to crash again the wall because the key is not here. I don't know why the PSO say, please pay attention. The minimum is 3, but the 3 is our wall. Is our, because it's our limit. This means the key PSO is clever, say, no, you are joking with me. The key is in the other room. You have to crash again. Should I see again? Should I show you again this LB? LB is the wall. You understand what I intend? I show you again because I don't see. I am not able to convince you. My key is in the other room. Why I am speaking about is outside of this room. Why that? Because our room, our search room, is this room here, which is defined between 3 and 4. This means I have to look of the minimum here inside, but the PSO is so clever that say, please pay attention. You have to crash again your wall, which is here, because I see that the minimum, I don't know where, but it's outside of this room, of my room, in which I told you, please look here. I try to put some trivial interpretation because otherwise it's really boring. No? But the meaning is clear. Now we will see why next week. It's really so clever, PSO. It works always. What is the meaning? It works always. It finds always something in the direction of the minimum. Because I know that the minimum is at point 2, but in the real world, no, God knows where the minimum is. But you see, the PSO said, please pay attention. You are joking with me. You have to go against the wall. Let me go a little bit ahead. It's a shame today I have to close a little bit early, but I will dedicate the whole lecture on last time. And then necessarily I have to switch on control, modeling, biological, Lotka-Volterra, you know, Lotka-Volterra equations? You know? You don't know. You know Lotka-Volterra. Pre-predator. Foxes, rabbits. Yeah, exactly. These chaotic, aperiodical oscillations on. COVID, it's Lotka-Volterra. COVID is no. Virology, COVID is this. COVID is infected, susceptible people who dies because of the infections. It's Lotka-Volterra. Because the people is infected try to infect the other one. We will see interesting this topic here, in which we will see the goal of the virus, which is not to extinguish the population. The goal of the virus to disseminate itself. Therefore, during the time, the virus will be weaker and weaker and weaker, because the goal is not to destroy the human, because if the virus destroys the human, destroy itself. We will see. Makes sense, no? In fact, the biologists demonstrate that the virus becomes, through mutation, becomes weaker and weaker and weaker, because the goal is to disseminate, not to destroy the human. By the way, I don't want to say the vaccination is not good, but the best we can demonstrate, the best way to work against, and the quarantine, isolation, because if you are isolated, you don't have the possibility to go. But of course, you have to limit the life. And then, okay, let me go ahead here. Let me. We will see. I have to tell you about that because in the title also, it is biological, economic. I have to consider also model in parametric form. This means for each particle for each n. I fix this two for loops means at each n, I will fill up the coordinates. In this case, it's extremely easy because n equal 1, m equal 1. This means I will put a value of for the first particle between LB and UB. I don't know if you remember this expression here from high school. I try to explain. If random is, I told you, is between 0 and 1. Randomly, uniform randomly. This means the distribution is a constant and the mean value is 0,5. Look, if random is 0, I have an LB. If random is 1, I have an UB. But random is between 0 and 1. This means the distribution of my coordinate, because everything changed with respect to J, which is just 1, is between LB and UB for each n. When I run this run is extremely easy if I have just one dimension, because it's just 1. Randomly, between 0 and 1, I will increase this. This means the second particle, I do the same. Yeah, please.
Between 0 and 1, does it mean if it's 0 that like all the numbers are the same? And if it's 1,
Is
all of them are different?
If basically at each, I clarify again, at each, let me say 4, this 4, the random can be between 0 and 1, but you don't know which number. This means if.
So like between 3 and 4.
Cannot be. Yeah, clear. Because, excuse me, it changes between LB and UB. If you look here, this expression here, I told you at the beginning, excuse me for this expression here says, if you think that Rn and D, this random function, change between 0 and 1, this is the assumption. It's the definition of at the beginning. If you consider not the distribution is different. In any case, now it changes between 0 and 1. If you think about this is changing between 0 and 1. This expression changed between 3 and 4. No, what this was the UB. Randomly. At each J loop or the for loop. Basically, you distribute n particles between 3 and 4 randomly. To express again, if this is 0, you are in LB. If this is 1, you are in UB. Look, you can see from math. If this is 0, you put the position LB at point 3. If randomly this is 1, you put your particle, when this is 1, at UB. How is realized in the computer? Yeah, randomly means that we will take the voltage. This is a little bit complicated from the converter, which is random in the sense, because of noise, because of. I don't know if I was able to explain this two loops. Talk, I will next week. Yeah.
Minus numbers of these terms, so like point, like 2 numbers, and we don't find any minimum.
At this moment, no minimum, because in the initialization phase, very important to look. Let me conclude until it's a shame a little bit longer. We have initialization phase. Now I changed the name. Just change the name. In X, I will put what I had in X0. I initialize I initialize also V. Why 0,1 is the normal practice, but no particular reason to start with this value. But anyway, you can find different initial values in different consideration. Let me skip this discussion about this, as initialization is always a big problem. There is also variation which we randomize again, but doesn't make much sense yet. But you have already a randomized variable x0. Look here, and then we will conclude for today. I would like to conclude here. What I am doing this for, I call my function, which I named out function. Remember at the beginning of today, I told you. This means call in this context means I will calculate, call is correct the name, no? I will calculate the function which I call. I can call also the function, but I need that. And I calculate the function at all these positions, n particle. This is a way to represent for each I all columns, all coordinates. In this case, we have just one. Because you remember, x0 is the column of n particles. Why is it a column? Because the dimension of the problem is 1. We have just a coordinate, because we have just a parabola. And I save these values in a column. Why that? Because I put just the value 1 here, with its values. Could be 200, 201, it depends. I show you now with the simulation. What I do now, I calculate with the function minimum, which is in the function of MATLAB. I don't need to program myself. What is the minimum here? As initialization minimum. I have basically a vector. And look, what is the minimum? It's in the program of MATLAB. And I save the minimum. This is the meaning of this comment. Basically, this min is in a function we could be also considered with some options, but calculate the minimum of this vector here and put the minimum in this first output and the position of the minimum. I mean, it could be that the bird number 3, find the minimum, find, it's not correct, correspond the minimum, because we use the word find when we move. I never speak about movement at this point. We are just in the initialization phase. This means I try to do in a photograph, in a photo of this. I map the value of the function in accordance with the position of my n particles. Let me stop here. Next week, I will clarify, starting from here, P best and G best, because we are close to fly, to run. If you think about the birds, we will see tolerance is not important for us because we will inject in between. Iteration is our indicator for the steps. I have to define the P best and G best we will see. And then with this while, which I clarify next week, we will fly. The last things for today, 2 things. In G best, I will put the best bird. Why that? Because I will put all possible coordinates, 1 in our case, and here I save which particle, which bird have the best. In G best, I have the best bird. The best bird is the bird which have in the hand somewhere the best value, the best word. Just question me. Yeah, I will do it. Yeah, when is the deadline for the project? We have time. Huh? I will do it. More information about how we can structure the project and so on. I will do it, believe me, because I'm always considering that we have a lot of lecture, but we don't have many. No? We have just 1 month. One month and 2 weeks, something like that. before going, look about just two things. X0. Do you remember a column of X0 value? You remember I told you it's in a column? The other is F0, no? It's in a column with the minimum. Let me run a little bit more concretely, and then we will see. I mean, what is the meaning concretely? Let me include in the lower and upper bound. Where is the lower upper bound? Here. Yeah. The minimum was in 2, no? Let me put 1. In order to answer your question. Yeah, we can see the numerical error, but it's close to 1. We can see 100 because in the calculation, I put somehow that he should round. Look what happens. Plot the function was fmin plot. No? I will clarify how I can build fmin plot, but I told you each time I put the minimum which I find. Look. Let me share also. I didn't put the grid, and next time we will put also the grid. Let me write the grid, probably we can see better. Look. The question is, starting from here, probably it does not work well to go ahead. You can see very quickly from this initial value, randomly calculated, the algorithm is going to this, then slowly here. Could be that it makes sense to stop here, or it makes sense, you have an stagnation region. Why we have a stagnation region? This is very tough problem. It's not the topic of the lecture. Otherwise, I cannot tell you about Lotka Volterra, COVID, and so on. But in the project, we can also go in depth on this. Now, your question, it's not relevant this way. You can put a lot of, also much more. Very important to look what happens during the movement. At this moment, I didn't tell you about the stagnation. I didn't tell you about the movement. Next week, this is the topic of next week. I dedicate the full lecture because I have to conclude very well this, I hope. And then I have to tell you about the project and some possible variation without clarifying much. If you look here, you can with the zoom, you can look a little bit better, but also with some specific command, you can a little bit analyze what happens more in detail. You can see an stagnation also at the beginning. This means, of course, we can think to improve the algorithm. This is not easy. This is PhD program. Yeah. Did you look in Stanford PSO PhD thesis? Look if you want. Why variation is not exactly the topic of the variation here in this course, but look, for instance, here. I don't know if you see. Yeah, we have also variation, but I don't have time. It's very important to understand the basic structure because every variation starts from these two important equations, which I clarified last time. Update the position, update the velocity. But if the velocity is too slow, we can think about to stop. But when we stop, if we are far away, it's a big problem. Therefore, PhD thesis. We have here two stagnations period, or that region, the period. Why not period? Because it's over time, no? Look at this again. Let me share. Or if you want the three stagnation, one until, I don't know, 40, we can see. The other one from here is not exactly stagnation, but we don't improve much for a long time. And then we have also a very long stagnation from 200 circa 1,000. This means, of course, we can think why I have to wait 1,000 here or 1,000 step. I didn't define time with the step. TikTok, we will see a little bit the next time, but it's clear what if I put inside TikTok a variation in order to improve, it's not the case because TikTok is not in the flying, it's just initialization at this moment. Very important. Also, the initialization is not trivial, but very important when I move, how much time, calculation time I need. This means depends of the command, which I have to improve to eliminate, to reduce this stagnation period or stagnation region, to avoid this stagnation. PSO is the topic. I try to give you just some flashes. Next week, I never have to conclude, even though it's a very, very huge topic. Okay, if I have a question, I have a few minutes for you. Otherwise, I promise that I will clarify a little bit the project, but don't care about the project. Every student will receive a project which is reachable. You have to tell me your desire, not what you desire as a mark. This is not but what you want to do, and then in your background. And then I try to, because here's complementary classes. It's not, I have to look at your background. And then you also desire what you want to do. And then the goal is reachable. Is reachable. I don't think, I know that it's difficult to follow me also because, yeah. Okay. Thank you. I'm here nevertheless for questions. I don't have much time, but today it's a shame.